this is Capt Chaudhari. In my series of videos on marine astronomical navigation, today I'm going to talk about an extremely important aspect of the lunar eclipse and the solar eclipse. Now, a question is asked why every full moon or new moon is not an eclipse. We've answered that question to a considerable extent, but sometimes a question is asked what are the maximum number of eclipses which can happen in a year, and what is the minimum number of eclipses, and if the minimum number of eclipses are these many, then what kind of eclipses they will be, solar or lunar eclipse. Let's try and understand this subject. A little complicated, but definitely interesting. Let us say this is the ecliptic, and as you know, in the great circle, ecliptic represents the path of the sun. Let us say I have projected also the great circle representing the moon's orbit, right? Moon's orbit in the celestial sphere becomes as big as the ecliptic itself, because distances are not important in the celestial sphere concept. So let us say this is the earth, and let us say the moon revolves around the earth. This is more realistic. Okay, and let us say this is representing one of the nodal points, and this is representing another nodal point. Now we must understand that as far as the moon's nodes are concerned, there is a distance with respect to the nodes or from nodes that the moon should be there, right? Moon in its orbit should be close to nodal points. I told you earlier that that is a condition for the solar or lunar eclipse. So let us try and understand the philosophy of eclipse, right? While the sun travels on this great circle that is ecliptic, if the sun is over here, right, and for any eclipse to take place, moon should be either here or here. But if the moon is over here, or the projected position of the moon is over here or here, you are not going to have any eclipse. Because for an eclipse to take place, the projected position of the moon should be between these markings, right? So there is no point trying to know whether the eclipse will take place when the sun is here. When the sun is here, moon can be here for conjunction or opposition, but moon is not within these arcs, so eclipse cannot take place. For the eclipse to take place, when we look at the moon's orbit here, the projected position of the moon should be within these arcs, right? By these colored arcs, I am representing only the position of moon. The moon has to be within this arc for a lunar eclipse, and moon has to be between these arcs. Moon has to be between these arcs for solar eclipse. So so the diagram is a little confusing, because actually what I am showing, this great circle is the sun's path, but I want the projected position of the moon to be within this for any eclipse to take place. Now, how many maximum eclipses can take place in a year? So they say 7 eclipses, out of which 5 eclipses would be solar eclipses, and 2 of them will be lunar. How is that possible? First of all, the solar eclipse get a benefit of a higher ecliptic limits. That means moon can be at more distance from the nodal point for a solar eclipse to occur, but moon has to be closer to the nodal points, for a lunar eclipse to occur. Let us assume that there was an year when you had 7 eclipses in that year. In that calendar year, you had 7 eclipses. How is that possible? So it was 1935 that we had 7 eclipses in that calendar year, and next it's going to happen only in 2206 AD. So it is an extremely rare thing that you will have 7 eclipses. But when can that happen? To know that, let us first understand that the regression of the nodal points is at the rate of 19 degrees 21 minutes, of course westerly. Now sun in the ecliptic on the easterly journey moves at the rate of 360 degrees per 365.25 days. The nodal points are moving in westerly direction and the sun is moving in easterly direction. If we combine the two, we find that there is a movement of 360 degrees plus 19 degrees 21, that is 379 degrees 21 minutes in 365.25 days. So if there is a separation of sun and nodal points at the rate of 379 degrees 21 minutes in 365.25 days, so for a separation of 360 degrees, let us say how many days it is going to take. 379 for 21 minutes we can write 0.35. So 360 into 365.25, 379.35. That gives me 346.62. 346.62. That means, suppose on a particular day you have the ascending node, the point at which the moon goes from south of ecliptic to north of ecliptic, that is called the nodal point, that is ascending node. On a particular day when ascending node and sun are together, after 346.62 days, once again the ascending node is going to be with the sun. So we call it as synodic period of the nodal points, 346.62. There is another calculation which we must understand, like a simple calculation. 346.62 days, 360 degrees is the separation between the nodal point and the sun. So in 29.5 days, how much is the separation? So it can be found by the simple calculation. So we have 360 multiplied by 29.5 equals divided by 346.62, 30.64 or something like that. That is 30 degrees and you can say approximately 30 minutes. 30 degrees and 38 minutes. So 30 degrees 38 minutes is the separation between the nodal points. So if we assume that the nodal points are fixed and only sun is moving, the separation between the nodal point and sun will be 30 degrees 38 minutes. So let us see how many maximum eclipses can take place in a year. So let's say on the 1st January of any calendar year the sun was here, right? And when the sun was here, right, moon was here, we had one solar eclipse. After about 15 days, when the sun comes here, and during its journey in 15 days the moon comes here, moon opposite to the sun, we have lunar eclipse. Then once again it so happens that the sun travels and sun is still inside the solar limit, and we have once again the moon coming between the earth and the sun. We have another solar eclipse. Now we know that in one lunar month the travel of sun or separation of the sun from the nodal point is 30 degrees 38 minutes. So 30 degrees 38 minutes multiplied by 6 lunar months, that gives me 183.8 degrees, just a little over 180 degrees. So after 6 lunar months, sun would come from here to here, which means that 15 days before probably the sun was here and 15 days after the sun would be here, and both these positions are favorite for the eclipses to take place because the projected position of the moon would be here. So this situation where the sun is here, ideal for the solar eclipse. This situation of the sun is also ideal for the solar eclipse, and in between, when the sun comes here, probably the position of moon here would give lunar eclipse. So we have two solar eclipses here, and two lunar eclipses, which means that we have 4 solar eclipses and 2 lunar eclipses. And this is witnessed within the travel of sun from here till here. The condition is, in that particular calendar, right in the beginning of the calendar year, say 1st Jan or something like that, the sun was here. Let's now talk about a situation where the eclipses in the year would be minimum. Let's say in the beginning of the month, the sun was here, right, while the moon was here. So this was a situation of conjunction and definite probability of solar eclipse. But let us assume that the sun was in such a position that 15 days before, while the sun was here, the projected position of the moon was not in the blue, projected position of the moon was in the red, which means that if it is an opposition situation, the lunar eclipse will not take place. But because for lunar eclipse, the moon projected position should be in blue. At the same time, when the sun reaches here, the projected position of the moon on the other side for the opposition, during opposition, is not in the blue, it is in the red. That means you would have a solar eclipse here and you would not have any lunar eclipse. Of course, the sun's journey in this as well as this part of the ecliptic, there is no possibility of any kind of eclipse. Similar thing to what happened here could be repeated here, right? You would have a solar eclipse here and there would be no lunar eclipse. So you have seen that it's possible that when we talk about the minimum number of eclipses, there have to be 2 eclipses, and both the eclipses would be solar eclipses.